Okay, welcome to this explainer. Today we're going to put on our detective hats and dig into exactly how advanced analytics can translate into real, actionable strategies for a loan portfolio. We've got a fascinating data set to work with, exactly 7,151 Lending Club loans. And our goal today isn't just to stare at a bunch of data, it's to uncover the actual story hiding inside those numbers. So right off the bat, let's introduce the central villain of our story, 16.9%. That is the charge-off rate on these loans. Now, if you're in the lending business, having almost 17% of your loans go bad, that is a massive financial leak. That's the core mystery we need to investigate and ultimately figure out how to plug.
To crack this case, our agenda is pretty straightforward. We'll start with the lending landscape, move on to predicting defaults, then estimating losses, profiling borrowers, and finally, deciding on our strategic business actions.
Section 1. The lending landscape. Our very first major clue, interest rates. The data reveals a glaring gap right out of the gate. Charged-off loans have a significantly higher median interest rate of 12.29%, compared to just 9.49% for fully paid loans. This tells us immediately that the initial risk assessment by Lending Club was definitely picking up on something, right? They were actively pricing those riskier loans higher. When you look at how these interest rates are distributed across the entire portfolio, they're heavily concentrated in the low to mid-range, specifically between 5 and 15%. The sheer volume of loans really drops off a cliff once you push past that 15% mark. Now, this is really interesting. Once we remove the massive annual income outliers, we find a modest negative correlation of minus 0.253. Basically, borrowers who have higher annual incomes generally end up receiving slightly lower interest rates. It makes intuitive sense, of course, but seeing the actual mathematical proof really validates our starting assumptions. Section 2, Predicting Loan Defaults. All right, before we grade the actual model results, let's quickly define AUC, or area under the curve. This is how we're scoring our predictive models. The rule of thumb here is simple. The closer a model's score gets to 1.0, the better it is at perfectly separating the good loans from the bad ones. Well, the results are in, and it's a dead heat at the top. The neural network and the improved boosted tree tied for top-tier performance, each delivering a validation AUC of 0.704. The basic classification tree lagged behind a bit at 0.658, which proves that applying boosting techniques dramatically lifted its performance to tie for first place. So, what's the big takeaway? It's really twofold. First, the interest rate variable was absolutely the single strongest predictive signal for a default. But second, and this is incredibly important for business leaders, a much simpler logistic regression model scored an impressive 0.703. It performed almost identically to our highly complex neural network. Keep that in your back pocket, because we're going to come back to it later.
Section 3, Estimating Financial Losses.
Now that we know who might default, we need to know how much it's going to cost us. To judge these regression models, we have to swap our scoring metric to RMSE, or root mean square error. Unlike AUC, here we're measuring prediction error, so we want this number to be as low as humanly possible. And the crown goes to the improved neural network. It produced the absolute lowest RMSE at 1,980. It minimized our prediction error significantly better than the standard regression tree, which was way up at 2,265. Just like with our classification models, a primary signal jumped right out at us. This time, installment amount was the strongest variable. And similarly, while that complex neural network was definitely the most accurate, the standard linear regression model remained a very strong benchmark at 2014. It's incredibly easy to explain to people, yet still highly effective. Section 4, Profiling Borrower Segments. To really understand our portfolio, we grouped 7,148 loans using K-means clustering. The vast majority ended up falling into the first two mainstream segments. Cluster 1 has over 2,200 loans, and Cluster 2 is right on its heels. But honestly, the magic really happens when we look at the smaller outlier clusters. Okay, I know a statistical heat map of normalized centroids looks like a giant wall of intimidating math at first glance, but it's actually our secret decoder ring. By looking at these normalized standard deviations, we can see exactly where specific borrower groups wildly deviate from the average portfolio behavior. Let's turn that math into actual human personas. Cluster 3, those are large loan borrowers,
big loan amounts with big monthly installments. Cluster 4 is driven entirely by borrowers who have tons of open accounts. And Cluster 5 is a tiny, super exclusive group of just 46 high-rolling individuals. We're talking massive annual incomes and extraordinarily huge revolving balances.
Section 5. Strategic Business Actions. All right, time to put all these clues together. We absolutely need a multi-pronged approach here. First, we have to actively combine our classification and loss models, because it's not enough to just know who defaults. We need to pinpoint the exact loans that are both likely to default and incredibly expensive if they actually do. Second, we have to heavily monitor those high-interest originations post-funding. And third, we should use those 5 borrower clusters to completely customize our underwriting and pricing strategies.
But here is the million-dollar dilemma we uncovered for leadership. It's a massive trade-off. Do we prioritize the sheer prediction quality and raw power of complex neural networks and boosted trees? Or do we rely on the slightly less powerful but vastly simpler linear and logistic regressions? Because at the end of the day, stakeholders, regulators, and internal teams can actually understand and explain those simpler models.
Which leaves us with a fascinating question for you. The data science is incredibly powerful, as we've seen today. But as you deploy these types of advanced analytics in your own business, how are you going to strike the right balance between maximum model accuracy and vital human explainability? Think about that as you look at your own data. Thanks for joining me on this explainer, and I will catch you on the next one.